Welcome back to Hardware Unboxed. It's time for a CES news recap and analysis. There's been a lot of announcements this week, including AMD's presentation, which has just concluded. So let's run through all the interesting stuff and give our thoughts on what has been shown.
Today's sponsor spot is brought to you by Thermal Grizzly and their new 12th gen CPU contact frame by DeBauer. It's well known that the integrated loading mechanism, or ILM, of the LJ1700 sockets bends 12th gen CPUs, leading to an uneven contact surface that reduces cooling performance. Solving this issue, the contact frame replaces the ILM, allowing for a much more even contact with the CPU's IHS and the base of your cooler, which in turn reduces operating temperatures. Installation's quick and easy, and thanks to the use of anodized aluminium, the contact frame is non-conductive. And then, for those of you who wish to further maximize contact, Thermal Grizzly now offers an optional lapping tool, so for more information, please check the link in the video description.
First up, I'll talk about the biggest reveal from the show, which has been AMD's new Ryzen 7000 3D V-Cache processors. V-Cache first debuted on the highly popular Ryzen 7 5800X 3D last year, stacking a cache die on top of the CPU chiplet to significantly increase total L3 cache capacity from 32 to 96 megabytes. The same sort of technology is now being deployed to Zen 4 Ryzen 7000 processors as well. While previously AMD only launched one V-Cache processor in their Zen 3 lineup, with Zen 4 that's being increased to 3 options. There's the 7800X 3D offering 8 cores and 16 threads, the 7900X 3D offering 12 cores and 24 threads, and the 7950X 3D with 16 cores and 32 threads. All are 120 watt parts and all will be available in February of 2023, so that's very soon. There's a couple of interesting things to note about these specs. First is the clock speeds. With the 7950X 3D, we see the same 5.7 GHz max clock as the 7950X. So unlike with the 5800X 3D versus 5800X, there's no reduction in turbo speed. However, to drop the TDP from 170 to 120 watts, base clocks are lower and we'd expect all core frequencies in typical applications to be lower than that of the 7950X. Similar with the 7900X 3D, which has the same 5.6 GHz max frequency as the 7900X. However, this isn't the case for the 7800X 3D, which lists just a 5 GHz max turbo clock. So this is down from the 5.4 GHz max frequency we saw for the Ryzen 7 7700X. The large cache should offset this clock speed drop like we saw for the 5800X 3D versus 5800X, though this frequency reduction is larger with the Zen 4 8-core part compared to Zen 3. Also interesting to note are the total cache figures. AMD lists both L3 and L2 cache combined, and the 7800X 3D numbers make perfect sense. 32 meg of on-chiplet L3 cache, 64 meg of 3D V cache, and 8 meg of L2 cache with 1 meg per core with Zen 4. This totals 104 megabytes. With the Ryzen 9 parts though, we have 140 and 144 megabytes of combined cache listed. This suggests only one of the 2 CPU core chiplets has received V-Cache. The 7950X already has 64 megabytes of L3 plus 16 megabytes of L2, or 80 meg of total cache. To jump up to 144 megabytes as seen here, there must be just 64 meg of additional V-Cache, which implies one set of V-Cache on one chiplet, while the other chiplet is just a regular chiplet with no V-Cache. That's an interesting configuration that seems optimized primarily for gaming, as most games avoid using more than one chiplet on AMD's dual chiplet Ryzen 9 parts. It wouldn't make a lot of sense to add V-Cache to a chiplet that won't actually be used for gaming, but it also means that thread scheduling needs to be spot on for these parts, always allocating games to the CPU chiplet that contains V-Cache. This typically isn't an issue these days with AMD's flagship parts, but there can be outliers that don't work well, so we'll have to see how that goes when we test them. Otherwise, these new Ryzen 9 V-Cache parts look ideal for people that use their systems for both gaming and productivity. Something like the 7950X should offer excellent multi-thread performance while also having top-end speed for gaming, enhanced through a huge L3 cache on one die. AMD is claiming with their first-party benchmarks that you should definitely take with a huge grain of salt, that the 7800X 3D is between 21 and 30% faster than the 5800X 3D across a 4-game sample at 1080p using high image quality. That's a substantial gain in performance and should push this part into the top spot on the gaming chart. Indeed, AMD are claiming a 13 to 24% performance lead over the Core i9-13900K with the 7950X3D. Previously, the 13900K has been the top gaming part, but AMD's marketing is now suggesting otherwise. No direct performance comparisons were shown pitting Zen 4 against Zen 4 Vcache, but we know the 5800X3D, 13900K and Zen 4 are all quite competitive, so these new X3D parts should be around 15% faster than Zen 4, a similar uplift from Vcache that we saw with the previous generation. There's not much else here to say on Zen 4 3D Vcache parts other than they will be arriving soon, so gamers won't have to wait too long to see what they will bring. Hopefully this will breathe some life into the AM5 platform, which has been struggling a bit from low sales and interest compared to AM4. The next major announcement from CES has been the introduction of new affordable processors from both AMD and Intel. We've got the 65-watt non-X Zen 4 parts from AMD and the 13th gen non-K lineup from Intel. On the AMD side, there are 3 processors, so quite a compact series. The Ryzen 9 7900 is basically a 7900X, with the max clock dropped from 5.6 to 5.4 GHz and lower multi-core clocks as the TDP drops from 170 to 65 watts. This part will come in at $430, down from the 7900X's launch price of $550, though these days the 7900X can be found for around $460 US, so it's less of a dramatic discount. Similar story for the Ryzen 7 7700 and Ryzen 5 7600. The TDP drop isn't as dramatic here as both parts go from 105 to 65 watts and clock speeds are down either 100 or 200 MHz in terms of boost clock. The big improvement is in pricing, with the 7700 sitting at $330 and the 7600 at $230, which are both $70 discounts compared to the launch pricing of the X models. However, like with the 7900, they're less of a discount relative to current pricing, as the 7700X can be found for just $345, while the 7600X has occasionally fallen to $260. So the new non-X models are cheaper, but they aren't radically cheaper, though it is always good to see price movement. When buying a non-X model, you'll also get an included box cooler, the Wraith Prism for the Ryzen 7 and 9, and a Wraith Stealth for the 7600. Zen 4 CPUs previously did not come with a box cooler, but it makes sense that the more affordable budget models would go back to including these. On the Intel side, as is typical for them, they've announced a huge suite of new locked non-K models for affordable systems. These include both standard models with integrated graphics and F models without integrated graphics, most of which are 65-watt parts. There's also the T series, which drops the TDP further to 35 watts, though these parts are mostly destined for pre-builds. For the higher end parts in the lineup, the core configuration is identical to Intel's unlocked Raptor Lake models. So for example, the Core i7 13700 has 8P and 8E cores, which is also true of the 13700K. However, clock speeds are lower, dropping from 5.4 to 5.2 GHz on the P cores and 4.2 to 4.1 GHz on the E cores. When run in its TDP limited state at its default 65 watts, all core frequencies will be a lot lower than the 125 watt unlocked models. However, many motherboards will run these in a power unlimited state by default, reducing the margins and increasing performance. While all of these parts are 13th gen models, Intel are using a mixture of Raptor Lake and Alder Lake silicon, though it's not 100% clear which CPUs use which architecture. It's expected that the Core i7 and Core i9 parts are Raptor Lake, while the Core i5s and below are refreshed Alder Lake. But that doesn't mean we are seeing the exact same configurations as 12th gen. The 13400F, for example, is now a 10-core processor with 6 P cores and 4 E cores. The popular 12400F was just a 6-core model with 6 P cores and no E cores, meaning the entire Core i5 lineup with 13th gen now has E cores. The Core i3 models are still quad-core processors though, with no E cores, and seem to be just higher clocked variants of 12th gen parts. Pricing has increased for all of these locked processors compared to the previous generation. For example, the Core i5 13400F now has a base RCP of $196 US compared to $167 for the 12400F at launch, and that has since increased to $184 in 2023. RCP is Intel's recommended customer price, which is not a true MSRP. The 13400F is actually listed for $210 at Newegg, pitting itself just $20 less than the Ryzen 5 7600, which should be an interesting battle. Similarly, the Core i3 13100F is listed with an RCP of $109, On Newegg, it's $125. The Core i7-13700F is $380, slotting between the Ryzen 7 7700 and Ryzen 9 7900, while the new Core i9-13900F comes in at $570 US, which is the exact same price as the Ryzen 9 7950X goes for these days. It is a little confusing that Intel lists RCP instead of MSRP. The RCP is typically more of a 1K unit price for bulk customers, but they've done this for a while now. I think it is important to note that you won't actually see the Core i5-13400F for $196, at least initially, as the MSRP is a bit higher than what has been listed in these slides. A lot of the first-party performance data provided by Intel and AMD for their new, more budget-friendly CPUs isn't that relevant, as both brands are launching new models at the same time. What is relevant is seeing how these 13th gen parts compare to the Zen 4 parts at the same price point, whereas Intel and AMD mostly focused on gains either comparing to the previous generation or comparisons to their competitors' last-gen parts. Of course, they couldn't have each tested each other's unreleased CPUs when making these charts, so for these models, benchmarking is going to be king, and we'll start to see those results very soon. Intel's new 13th gen models are available to buy right now, while the AMD Zen 4 non-X parts are debuting on January 10th, so look out for our review soon. Lastly, let's talk about laptop hardware. All three big hardware vendors are launching new laptop chips in the first quarter of 2023. We have new CPUs from Intel and AMD, plus new GPUs from Nvidia and AMD as well. So let's break it all down quickly for you. Starting with CPUs, at the top of the stacks from both AMD and Intel, we have the best silicon on offer that's destined for high-end gaming and creator laptops. For AMD, that's the Dragon range, featuring up to 16 Zen 4 CPU cores, DDR5 memory, and 5nm process technology. These processors are designated into the Ryzen 7045HX series and appear to be using the same silicon as desktop Ryzen 7000 processors. In other words, the multi-die design with an I/O die and up to 2 CPU core chiplets. These are designed for laptops running in the 45 watt plus TDP range or 55 watts and over for the flagship model. The top chip in this line is the Ryzen 9 7945HX that offers 16 cores, so that's a big upgrade from the 8 cores last generation, 80 megabytes of L3 plus L2 cache, and up to a 5.4 GHz boost clock. This is basically a Ryzen 9 7950X power limited to a laptop form factor, or at least that's what it looks like, and of course it does have slightly lower clock speeds. But there's also 3 other models encompassing the Ryzen 9 7845HX with 12 cores, the Ryzen 7 7745HX with 8 cores, and Ryzen 5 7645HX with 6 cores. These are designed to be paired with discrete graphics, and all will be available starting in February. On the Intel side of things, their competition is the Raptor Lake HX series, which is very similar to what AMD is doing, bringing the top specs of the desktop platform to laptops in a more power-limited configuration. Intel are offering more SKUs, but the basic configurations are similar and all come with a base power rating of 55 watts, indicating they are designed for larger form factor devices. The top has the Core i9 range, which feature 24 cores split into 8 performance cores and 16 efficient cores. This is the same configuration as the Core i9-13900K, but slightly lower clocks topping out at 5.6 GHz, as well as generally lower operating frequencies due to the much lower TDP and max turbo power. This is a very similar design principle to what AMD is doing, though of course Intel was first to this sort of configuration as they debuted HX processors with the 12th generation line last year. As we move down the stack, we get the Core i7-13850HX with 8P cores and 12E cores, and then 2 other Core i7s, one with 8P and 8E cores, the other with 6P and 8E cores. It seems that from the Core i7-13700HX and down, Intel are using older Lake dies, similar to the split we saw with 13th gen desktop processors, where the lower tier models are using older silicon. The tiers have shifted though. The old Core i9-12950HX effectively becomes the 13700HX with a frequency boost, so that brings this performance to new price points. Then further down this stack, we have the Core i5s with 6P cores and either 8 or 4E cores depending on the model. The next tier down from these HX series processors are the H series from both brands. On the AMD side, that's the Ryzen 7040 series, a new monolithic APU that combines Zen 4 technology with RDNA 3 integrated graphics and a new AMD XDNA AI engine, all using TSMC's N4 node, a derivative of their 5nm tech. For AMD's parts, they've decided to ditch the regular H series and only offer HS series parts, which are generally intended for slimmer, more portable 14 and 15-inch laptops. These all have a TDP range of 35 to 45 watts and include three models, the Ryzen 9 7940HS and Ryzen 7 7840HS, which are both 8-core CPUs, and the Ryzen 5 7640HS with 6 cores. Clock speeds are increased here. The flagship model jumps from 4.8 to 5.2 GHz, and there's more cache with 32 meg of L3 up from 16 meg in the previous generation, which matches the desktop lineup in cache capacity, a decent step forward for their monolithic APU option. On top of this, the 7040 series offers up to 12 RDNA 3 compute units, replacing the 12 RDNA 2 compute units in the previous generation Ryzen 6000 APUs. There's also a new AI engine that AMD spent some time talking about, which they claim is more efficient and faster than the Apple M2 AI engine. These HS series models, codenamed Phoenix, will be available starting in March. Intel's competition to this is the H series, including a huge range of processors. These are 45-watt models in contrast to AMD more targeting the 35-watt range, so we'll probably see them in a slightly higher tier and in more gaming-focused models. The Core i7 and Core i9 models mostly feature 6P cores and 8E core configurations, with some models featuring nearly identical specifications. As we move down the stack, we have a few outliers such as the Core i7 13620H that cuts the E cores in half, and then the Core i5 range which brings 4P cores and either 8 or 4 E cores, and of course lower frequencies. There's a lot of segmentation here at the higher end of the mobile CPU stack, with multiple offerings depending on the exact type of system an OEM wants to build. The HX series is likely where we'll see a lot of interest for top-end gaming laptops, as the CPU die features more cores and less integrated graphics, while the H and HS series from either brand drops the core count in favor of a beefier iGPU. The idea here being to offer more dedicated designs that better fit with the type of system being built. After all, a gaming laptop with discrete graphics really doesn't have any need for the larger RDNA 3 iGPU found in AMD's Phoenix APU as an example. Once again, I'm steering clear of some of the performance comparisons here because most of what is being discussed isn't that relevant to the laptop landscape in 2023. AMD compared their parts to Alder Lake, and Intel compared their parts to Ryzen 6000, but really 13th Gen and Zen 4 will compete against each other, and both will come to market at a very similar time. There's a few interesting tidbits in here looking at generational gains for gaming performance in comparisons to Apple hardware, but with laptop benchmarking, we're really going to have to test this for ourselves to see how it plays out. As we get further down the stack, AMD have the Ryzen 7035 series. These models are designed for premium thin and light notebooks in their, say, 28-watt range, though AMD is sticking with U series designation. These parts are a refresh of Ryzen 6000 U series, which used AMD's Rembrandt die. In the 7035 series, it's Rembrandt R, so a very similar use of Zen 3 plus CPU cores and up to 12 RDNA 2 compute units. We didn't get a ton of specs here, but we do know there will be a Ryzen 7 7735U, which is probably the highest tier part and a refresh of the Ryzen 7 6800U. What's interesting here is that AMD talked about the 7035 series for 28-watt systems, but didn't show any Phoenix 7040 designs in this power class, despite saying that Phoenix would be used for these sorts of laptops. Similarly, there will also be 7035 series SKUs in the HS series, going on this slide from AMD. The 7035 series for U series will largely be competing with Intel's 13th Gen P series processors, which are very similar to 12th Gen Alder Lake in design. This could be why AMD are focusing on Rembrandt R here rather than going to Zen 4. The 13th Gen P series includes 4 models designed for 28-watt class notebooks, the top-end model being the Core i7 1370P with 6P and 8E cores, the same design as the Core i7 1280P, but with a small increase to clock speeds. There's also another 3 CPUs that go with 4P and 8E cores. Then we get to the next tier down, which for AMD is the Ryzen 7030 series, which is using refreshed Barcelo silicon, which itself is a refresh of Cezanne from 2021, so a bit of a double refresh here. Up to 8 Zen 3 CPU cores, Vega graphics, we've seen this before, and while we're not getting specs for these models just yet, expect a very similar design to prior models. These will compete against Intel's U series, which again appear to be sort of a minor refresh on Alder Lake and stick to the 2P plus 8E core design for the most part with some clock speed adjustments. Both Intel and AMD didn't spend a lot of time discussing the new thin and light processors for this generation, so it seems most of the exciting laptop releases will be for larger gaming and productivity systems. Both companies are using a mixture of new silicon and refreshed silicon across the lineup, probably the most refreshed hardware seen in some time for a new generation of laptop processors. I also think these lineups on both sides are very confusing. AMD has the 7045 HX series, 7040 HS series, 7035U series, and 7030U series, all using different dies and the possibility for crossover between 7035 and 7040 in HS and U series. Intel then has the HX, HP, and U series with different configurations and power targets, plus plenty of SKUs. This is, well, it's great for OEMs that can pick a specific part that might be the best suited to their laptop design, but it's pretty terrible for consumers in terms of figuring out what chip they are buying and what performance it will deliver. It's even more confusing when a significant part of the lineup is so similar to previous generation parts, either in configuration or just utilization of refreshed silicon. Lastly, we have new GPU hardware. On the AMD side, it's not particularly exciting, as they're only launching a couple of mid-range SKUs using RDNA 3, the RX 7600M XT and RX 7600M, plus the S variants. Oddly, the 7600M XT becomes the 7700S for some reason. Specifications are very light on here for these Navi 33 designs. The only real info we have is 8GB of GDDR6 and a 128-bit memory bus, plus some FP32 numbers that aren't very useful. AMD are expecting the 7600M XT to deliver between 20 and 40% more performance than the RX 6600M, which would put it above the level of Nvidia's desktop RTX 3060. These 7600 series GPUs will be available starting in February. Meanwhile, the big news in the laptop GPU front is the launch of Nvidia's entire Ada Lovelace RTX 4000 series product stack, including the RTX 4090, 4080, 4070, 4060, and the RTX 4050. All of these are laptop GPUs, and despite the naming being identical to that of the desktop cards, but with laptop GPU slapped on the end, none of these will get close to their desktop counterparts. Things are getting so bad for Nvidia GPU naming that the RTX 4090 laptop GPU isn't even that close to the RTX 4090. It features 9,728 CUDA cores, clocked up to 2.04 GHz in the 150-watt configuration, alongside 16GB of GDDR6 memory on a 256-bit bus. The desktop RTX 4090, so the proper one, features 16,384 CUDA cores, clocked up to 2.52 GHz, and uses 24GB of GDDR6X on a 384-bit bus. There's nothing at all similar between these two parts, despite being both called RTX 4090, which is dumb and highly misleading for customers. Even the Ada Lovelace die isn't the same. The RTX 4090 for desktop uses 8102, whereas on laptops you're getting what appears to be 8103, which is then used for the RTX 4080 on desktop. This then pushes the RTX 4080 laptop GPU down a notch to using 8104 and specs well under the RTX 4080 on desktop. In fact, the 4080 on laptops doesn't even match the RTX 4070 Ti in CUDA core count. So Nvidia seems unwilling to admit that you just can't put the RTX 4090 in a laptop form factor, which of course was never going to happen given the size of RTX 4090 GPUs and their high power consumption with a 450-watt TDP. Laptops just can't handle that sort of power, with higher tier laptop models typically sitting in the 120 to 150-watt range. But rather than adjusting the name to account for this, like calling it the RTX 4090M or something like that, Nvidia are just calling it the RTX 4090. It'll be very interesting to benchmark these parts and compare it to the desktop model to see what the gulf is in performance, because on the naming side it just seems to be growing with each generation. I mean, back in the RTX 20 series days, yes, there was a difference in performance between laptop and desktop due to clock speeds and power limits, but at least you were getting a similar core configuration. These days, the laptop and desktop configurations are nothing alike, and the naming has only gotten more similar over time. It's also impossible to say what these sorts of GPUs will be bringing to laptop form factors, as Nvidia also didn't provide many realistic performance figures. The majority of numbers we did get compared Ada Lovelace to Ampere and Turing with features like DLSS 3 enabled exclusively on the RTX 40 series part, which means it's not an apples to apples comparison and is therefore useless. We did see 2 games included that didn't have this stuff enabled, which shows approximately a 50% performance uplift. It's pretty hard to see, but I think it's around 50%, which I guess is probably what you should expect most of the time. If we do get an uplift in that range, that will be quite decent, given laptops aren't able to increase power much further than they're already sitting at. But I would have preferred if Nvidia showed at least some more realistic performance gains that you would see in games. Of course, aside from performance, we will be seeing all the other advantages of Ada Lovelace brought to laptops, such as AV1 video encoding and DLSS 3 support. Nvidia also touted new Max-Q technologies designed to improve efficiency for these laptop models, such as even lower voltage GDDR6 and on-chip memory. What we do know is the RTX 4080 and RTX 4090 for laptops will become available starting February 8th in laptops priced above $2,000 US. The other models from the 4070 through 4050 will be available starting February 22nd in the $1,000 to $2,000 range. So, I guess that's pretty much our recap of the CES news from AMD, Intel, and Nvidia, all wrapped into this sort of one video. A lot of the focus at CES this year has been sort of on the laptop and mobile side of things. We're expecting pretty much everything to be refreshed in the next couple of months, so you should see quite a lot of laptop releases covering GPUs, CPUs, all that sort of good stuff from all the brands. So it's going to be pretty exciting to pit some of those new products up against one another. We get 16 core Zen 4 on laptops. That's very exciting. 24 cores on the Intel side as well. Of course, despite the stupid naming of Intel's Ada Lovelace GPUs for laptops, I am excited to see how much more performance we can get from the RTX 4090 and 4080 for laptops compared to the previous gen models. Maybe that will make laptop gaming even better this generation. So yeah, lots of exciting stuff to cover. If you are interested in more hardware unbox coverage of various different things, please do consider subscribing and supporting the channel via our Patreon and Floatplane accounts. Links to those are in the description below. Anyway, that's it for this one. Thanks for watching, and I'll catch you in the next one.